right. If you are tired of running manual queries to fulfill your data privacy requests, you are in the right place. My name is Guillermo Fisher. I am an AWS data hero and a fractional CTO and CISO, and I help companies solve engineering productivity, security, and compliance problems. And today, we're going to talk about modernizing privacy compliance workflows in AWS. So just to talk you through what we're going to be going through today, we're going to first talk about trends in data subject requests, or DSRs, why manual compliance is a suboptimal long-term solution. We're going to talk about what a cloud-native compliance solution looks like, walk through some lessons learned, the lessons that I've learned in the field, and then I'm going to leave you all with a practical blueprint that you can use to get started as soon as you get out of this conference. Last year, a little over a quarter of all internet users filed a DSR, and that makes a lot of sense. And you think about, GDPR and CCPA and other states rolling out, similar privacy laws. So, they're everywhere, and they're increasing by about 30% year over year, and we're going to continue to expect that kind of an increase. And they're expensive as well. So, if you consider companies that deal with around 1 million identities, spend a little bit less than $900,000 a year actually manually processing those data subject requests. And on average, it costs about $1,500 to manually process a DSR. So to bring that to life a little bit, I was working at a company. I was brought on to be the head of infrastructure. And one of the things I was responsible for doing was defining this DSR process. Within my first 90 days, the first privacy request came in. There was no process, no workflow. There might have been a form somewhere. So between meetings with legal, meetings with engineering and security, getting on Zoom, emails, et cetera, it took meetings with 6 very senior people, 40 hours of work, and we barely fulfill the request in time. So pretty expensive, pretty time-consuming, and pretty stressful. Doing all this manually might be okay for a smaller organization where you aren't getting that many requests, but it doesn't scale very well. Intake can come in through, or these requests can come in through forms, through emails that get sent to different people within the organization, through ticketing systems for something like Zendesk, or through Jira, or whatever it is that you're using. The handoffs that you are executing while you're trying to fulfill these requests can be undocumented. Things might slip through the cracks pretty easily. SLA deadlines, if they are tracked at all, they might be missed, or they're not communicated to people that need to be aware of how much time they might have to actually fulfill the request. And again, legal, security, engineering are spending a lot of time working on this stuff instead of doing some more potentially innovative work or doing the kind of things that you want them to be doing. I've started to ground these conversations with this really simple model of RVVR. That's receive, verify, validate, and respond. So in the receive step, you're obviously intaking the request, you're logging it, making sure that the clock starts on that request. The verify, you're actually making sure that the requester is who they say they are. With the validate step, you're making sure that this request is applicable to you and your business and that it is an actual legal request. And then on the response side, you're either sending the information to the person if it's an access request, deleting the information if it's a delete request, et cetera, et cetera. So this is pretty simple enough to talk about with somebody who is not technical, but great enough to capture all the essential pieces that an auditor would be looking for when you're communicating about the process to them. Here's an example of an actual manual process that was in place at a place where I worked. So the requests came in through Zendesk. There was a ticketing system in Zendesk, so people submitted customer support requests there. And then the data was distributed across RDS, and we had a data warehouse as well. So as we were verifying the request, we had to ask the user to provide some information and then check throughout these 2 different data stores to make sure that information was there. And then there was a lot of communication to validate the request. So in this particular instance, legal was outsourced. And so there was a lot of Zoom meetings and Slack conversations internally to make sure that this request was within the scope of what we needed to handle. And then once again, going through different data stores, we had, again, RDS for our transactional stuff, warehouse was in Redshift, and then we had to deliver the access request in Dropbox. So we packaged up CSVs, put them into Dropbox, and then popped the link into Zendesk and into that ticket so that the requester could have access to that data. So this worked. This definitely got the job done, but again, it took a long time. On average, it took around 7 days for us to fulfill these requests, and if somebody was on PTO, who was a necessary part of the workflow, it could take upwards of 2 weeks. So not only is this expensive because doing it manually, expensive because it takes up a lot of time, but getting it wrong can be incredibly expensive. In March of this year, the CPPA fined an automaker for not handling this stuff very well. They had poor consent workflows, bad third-party data sharing practices, and that isn't a reflection of their intention, right? It wasn't that they were trying to get this stuff wrong, they didn't do a good job of managing this process. And so this fine is real, this just happened this year, and this is something that you need to be aware of so that you know how serious it is to get this stuff wrong. So here's an example of a workflow that is cloud native. So we've got a bunch of different services here, and we're going to dive into each of these different pieces in a bit. But on the receive side, we've got API Gateway, Amazon API Gateway, kind of taking in the requests. We've got verification happening through the different through Lambda functions that are managed and orchestrated through step functions. We've got validate also happening through Lambda functions that are called through step functions, and then the respond step. We're compiling data into a structured format. We are delivering it to the user through SES and storing the data in S3. So all of these different RVVVR steps are being managed through a much more automated, much cleaner, much faster cloud native solution. First step we're going to take a look at is orchestration logic. Why step functions? Because step functions support out-of-the-box retries, timeouts. They also support any manual human intervention if that's needed, if something goes wrong. And then Lambda functions are pretty ubiquitous in general, but you can unit test unit test each of these different pieces individually. You can swap out different pieces for different kinds of requests, and it's pretty easy for folks to upgrade, refactor any of these if needed. Notifications and tracking. So this is a very important piece of the whole solution. You want to make sure that you are keeping track of the status of each of these steps in the process in some kind of a solution. DynamoDB is a great solution for this. You can track, when the request comes in, how different pieces of the process are being managed, how quickly they're being managed, and then you can use a solution like EventBridge to run frequent checks to make sure that you're staying on top of it. So if you have, for instance, less than 45 days left, and for some reason the request hasn't been fulfilled, you can actually schedule a check and then have that check trigger a notification using SNS, Amazon Simple Notification Service, to hit up Slack or PagerDuty or send an email to let you know that there's something wrong and that you are potentially in danger of not being able to fulfill this request in time. Again, storage and secure delivery. So using S3 is great for storing this stuff. Use restrictive IAM policies to make sure the right people have access to the data, and then use SES to deliver a pre-signed URL so that the requester gets access to it. You can time box access to that. So if, for instance, if 24 or 48 hours pass and they still haven't clicked on the link, then the link is no good anymore. They'll have to reach back out to you. But SES and S3 are great candidates for storage and delivery. Let's talk about why this is better in terms of a few different dimensions. So cost, of course, first and foremost. We already discussed that it's about $1,500 to manually process a DSR. With this solution, with this kind of a solution, less than $10 per request. And that factors in the dev time up front, that factors in time to refactor things and maintain the solution down the line, on average, about $10 a request, which is a steep decrease, definitely worth it to investigate and see if you can produce your own cloud native solution. Time to fulfill goes from days and weeks, like I said before. It could be 7 days, 2 weeks, potentially months, depending on the complexity of your data, to minutes and hours, or seconds even, if the data allows for that. Your risk here, in a manual workflow, like I said, things can potentially get dropped, slip through the cracks, so pretty high risk. With things more controlled and logging in place and auditing in place, it's much more controlled for the cloud native solution. And then auditability, we already talked about that. Having everything centralized in DynamoDB is a great benefit, so that when it comes to audit time, you already have stuff that you can present in DynamoDB and potentially in CloudTrail as well, so that access to different things is also tracked. Where I've seen teams go wrong in trying to implement these cloud native solutions is in 3 different areas in particular. And just to go outside of the scope of this talk, I think these 3 can be applied to any project where you're doing any kind of automation. So first and foremost, unclear handoffs between humans and automation. If you have to get involved as a human being and make a change or support something, there needs to be a pretty clear process that lays out what needs to happen as a result of your interaction. What happens next? Do you have to talk to somebody? Do you have to push a button? That needs to be laid out so that the process isn't unnecessarily haltered. Don't over-engineer the thing. Could you potentially build an LLM and have it fine-tuned to your data and your schema? Sure, you could, but it could take much longer to do that. You don't want to tie, for instance, the use of new technologies to a project like this, because you could potentially fail and not be able to use those technologies anymore if your company sees the lack of success for that thing and ties it to, for instance, Lambda functions if you haven't used them before, or Terraform if you haven't used that before. Don't try to boil the ocean, don't try to over-engineer, just do what needs to be done for that project. And then, of course, you want to build observability into it from day one, as early as possible. Do not treat it as an afterthought. What you can measure, you can manage, and so you want to make sure that you're measuring as much as possible, as early as possible. To get started, you want to go with one of your request types. You want to map that existing process, lay it all out, make sure you understand what's involved. You want to identify any pain points and risks that exist within that specific workflow. You want to choose one. Again, access requests are a great place to start. Delete requests are also pretty simple and a good place to start. And then you want to define what success looks like. So how long will it take us on average to do this manually? What does it look like if we do this using a cloud native solution? If that response time is days, then make sure you have a clear understanding of how many days or how many hours or how many seconds, whatever it is. Make sure that's clear and communicate it out to folks. Make sure you have an understanding of what cost savings you want to have and what the SLA is that you want to have in place. Right, automate one core workflow, use event-driven orchestration if possible, use services that you're familiar with. Again, you don't want to try to use this as an excuse to use some other service that you haven't used before. You want to be successful here, you want to get this done quickly, so use something that you know, and you want to make it testable so that you can test different parts of it to make sure it works, and again, be observable as early as possible. And once you're done automating all that, you want to start adding alerts, of course, and more metrics, more dashboards, et cetera. You want to start to build out more DSR types. So if you started with access, move on to delete and opt out, whatever the different request types are that you need to support. And then you want to make sure that as different people get involved and you start to build out for different request types, that you're standardizing different components of this solution. And then you want to also review it and treat it like a first-class application. Don't treat this like some one-off that exists somewhere else. This is now a part of your production workload, and you want to treat it as such. Start small, automate one request type well, use AWS native tools that you already know very well, build logging and metrics early, and then expand with confidence. And that's basically how you're going to get started. And that's all I have for you all. So that's my QR code. It's safe. This is me on LinkedIn. So just use that if you want to get in touch with me. I'll be over here to answer questions if you want. And please do fill out the survey for this session. And that's it. Thank you very much.